Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to concept videos from SOFO Learning. Today, let us review the relationship between the area of similar triangles. First, let us review what is meant by a similarity rule for two triangles. All right, so let's imagine two triangles, and let's say that these two angles are the same and these two angles are the same. Then naturally this angle and this angle would also be the same, because all of these angles has to sum up to 180 degrees. Now if all the angles are equal, then these two triangles are similar. In other words, their sides are proportional. So if this side was A and this side was B, then the proportion of A and B would be equal to the proportion of these two sides, say C and D. And similarly to these proportions, E. Alright, so this is basically the AA similarity rule, and we are going to apply this principle to assess the relationship between the area of two similar triangles. Now, I have here two triangles that we are given to be similar. So this triangle ABC, so let's write that down. Triangle ABC is similar to triangle PQR. Alright, now what that means is that the sides are essentially proportional. So let's write that down as well. Side AB by PQ, this is equal to BC by QR, which is also equal to AC by PR. Alright, now we need to think about the area of these triangles, because we are trying to assess the relationship between the area between these two triangles. Now area of a triangle is defined as half times base times height. Alright, now what would be the area of this? We need to think about the height. So let me just use a different color to mark the height, this being perpendicular. So let's mark this point as N, and similarly let's create a line, this perpendicular line to the base QR, and let's mark this line as M. So we can think of the base as BC, and this line running perpendicular to this base AN as the height. So that's similarly PM for QR for this triangle PQR. Right? So we can calculate the area using the length of these two sides. Now the area of triangle ABC would be 0.5 or half multiplied by base BC times height AN. And similarly, area of PQR is 0.5 times QR times PM. Right? So if we were to do this, right, ratio of the area is the ratio of these two expressions. Now let me just use a different color. So this 0.5 and this 0.5 would cancel each other, and you get these two pieces, BC by QR times AN by PM. So AN by PM. Now we need to think about what to do with these two lines, and we can convert by thinking about these two triangles, this triangle and this triangle. We need to think about that, and then based on that we can figure out how to convert. Now let's think about it. All right, we know that these two triangles are similar, therefore angle B would be equal to angle Q. All right, this B and this Q are equal. Similarly, this is 90 degrees and we know that this is 90 degrees as well. Therefore, we have two angles of this triangle and this triangle being equal. These two are in fact similar. Right? These two are in fact similar. So their corresponding ratio of their sides, the corresponding sides are equal. So one of the sides is AB and PQ. That's equal. That you have right here. All right? But another one is this AN and PM. All right? AN and PM. Now you can see that this is equal to BC by QR from previous expression. Right? So this AN can be written, AN by PM can be written as BC by QR itself, or the square of this BC by QR. All right, so there you have it. That is the relationship. So let me clean this up and write it again. Okay, so from the original area equation we have area ABC by PQR is equal to BC times AN times 0.5, of course, and divided by 0.5 times QR times PM, the base times height equation. So these two 0.5s cancel each other, and this AN by PM, by virtue of the fact that these two triangles are similar, this AN by PM is equal to AN by PM is equal to AB by PQ, which is also equal to BC by QR. This comes from the fact that the original larger triangle ABC and PQR are similar. Now we can just use this over here and we get the final form, area of ABC by area of PQR is equal to BC by QR squared. All right. Now, if we draw this AN in a different direction using this as the base, you would get a different set of sides. So if we keep doing this for each side separately, we can get AB by PQ squared is equal to AC by PR squared. All right. So there you have it. This is the expression that describes the fact that area of two similar triangles is proportional to the square of the proportion of its sides. Thank you for watching.